Hi everybody. In this video I'm going to walk through how to set things up so that you can take advantage of the UConn high performance computing cluster while working on your local machine in a Jupyter notebook in VScode. This is going to be useful if you're working with a large data set and you're pushing your laptop past its limits, because the cluster has many more resources than you're going to get on your typical personal laptop. So let's take it away. So the University of Connecticut actually, it operates a high-performance computing cluster where you can get multiple fast CPUs, you can get large amounts of memory, you can work with large amounts of disk space, and you can take advantage of enterprise GPUs, which are considerably more powerful even if you've invested in a video game GPU for your local computer. The disadvantage or the complication in using the cluster is that it's a shared resource, and so you have to be a good citizen while using it, because lots of other researchers are taking advantage of it, and you don't want to hog things when you're not actually using them. So we'll talk about that later. So there are actually two high-performance computing facilities at UConn. There's a cluster at the Farmington campus where the health center is, and it's set up for memory-intensive operations. There's also a cluster at Stores. That's the one we're going to use, and it's optimized for computing, for high-performance computation. If you'd like to learn the details of how the cluster, what's available at the cluster, and more about how to use it, you can read the documentation. The link is here. That'll take you to this web page, which will talk about the resources and the usage policy, and also how to work with batch jobs and so forth. As I said, the goal of these notes is to set up an environment on your local machine so that you can work locally in a Jupyter notebook using VScode, but the back-end compute engine for your Jupyter notebook is going to be on the cluster, so it can take advantage of these fast CPUs, these GPUs, this memory, and this disk space. You're going to need to know how to use VScode, and not just how to use VScode, but how to run Jupyter notebooks inside VScode, and just generally be familiar with VScode and also with its extensions, although I will walk through the crucial things that you need to know. We're going to have to work on the Unix command line because the cluster is basically a Unix machine and it doesn't have a graphical interface. So we're going to need to use the SSH command to connect to the cluster, and we're going to need to install Anaconda on the cluster using command line tools. So you're going to need to be able to open a terminal window on your local computer, whether it's a Mac, a Windows machine. This is actually a Linux desktop, but the differences aren't that significant. The most important thing is that you need to have SSH available on your computer. If you have a Mac, that shouldn't be a problem. Open a terminal window and just see if you have SSH. It shouldn't be a problem on Windows either, but you're going to need to open a terminal window and make sure you have SSH. If you don't, you're going to have to track down how to get that installed, because you won't be able to connect to the cluster without it. Some other things you're going to need on your local machine, well, the university VPN if you're going to be off campus, VScode, and you're going to need to make sure that you have the appropriate extensions to VScode installed. So the key things that you're going to need are the Jupyter extensions. So I have a VScode window open here, and if I look inside the extension section and I search for Jupyter, you can see there's a bunch of extensions related to Jupyter. The crucial one that you need is this one, Interactive Jupyter Notebook Support from Microsoft. So you want to make sure that that extension is installed on your in your VS Code. The other ones you're going to need are remote tunnels and remote SSH. So to see those, you can put in remote here. Whoops, you got to spell it right. And you'll see there's a whole bunch of extensions that have the name remote in them, but the crucial ones are remote SSH and remote tunnels. So you want to make sure that those are installed in VS Code. Otherwise, you're going to have to take a break and get that stuff in before the rest of this video is going to be of much help to you. Okay. Finally, you need an account on the cluster. If you're in the UConn data science program, you probably already have one. Your login name would be your NetID, and it would be your NetID password. If you don't have one and you're at UConn, you can request one. The link is here. You fill out this little form and say what you're going to do, and you can get an account. They may initially set it up with relatively limited resources by cluster standards, but it should be ample for anything that you're going to want to do. If you need more resources, then you'll have to talk to the administrators of the cluster, and they're probably going to want a letter from a faculty member or something like that. Okay, so let's get started. First of all, we're going to log into the cluster, but make sure that you've got the VPN running on your local machine if you're off campus. So we're in a command shell here, the terminal window, and this is, I have a prompt here, $. That indicates that this is a shell prompt, but the command is actually here. So I'm going to do SSH my NetID at hpc2.stores.hpc.uconn.edu. It's going to prompt me for my password, which I can't type. And which I have spelled wrong. I'll try one more time. There you go. And you'll get this, this message of the day here. Welcome to the UConn cluster. Some important information about disk space. It'll list if you have any batch jobs running, which we don't. And finally, you'll get down to this prompt where it'll say login 5. It may not say login 5, it'll say login something. So what you've done now is you've connected to one of the login nodes of the cluster. And these are the place where you start your voyage with high performance computing, but they are not intended to have any work done on them. So you don't do any serious work on a login node. And they're just, you could quickly check if you wanted to look and see about a file or something like that from a login node, that's fine, but you shouldn't do any computations. So what you need to do is to request a node on the cluster which has which is intended for computation. And the command for doing that is srun to start an interactive session. So if I run the srun command, I have to ask for what I want. Nodes equals 1 means I want one CPU. You could, I suppose, ask for more if you were going to do some kind of multiprocessing. Tasks equals 8 means I want at least 8 cores on my CPU. Mem equals 32G means I want 32 gigabytes of memory. Partition equals general. Well, that you don't have any choice about because for users like us, we're limited to the general partition. And finally, you can't quite see it here, but I'll scroll over. --pty bash. That means I want to connect using the bash shell. If I execute this command, you'll see that what I've actually done is put in a request for resources, a CPU with 8 cores and 32 gigabytes of memory on the general partition, which is where regular people do their work. And you have to wait. And in this case, I seem to have to wait a pretty long time. Okay, so I had a long wait there, and I edited some of it out. But normally, the wait is not that long. But you notice that what's happened now is it's told me that I have been allocated resources, and the prompt has changed so that it now says CN458. So CN stands for compute node, and I've now been logged into CN458. Okay, let's get back to work here. This is a little bit of a detour, but since if you haven't used the cluster at all before, you won't have any of the machine learning tools from the Anaconda package installed. They're not installed. They're not available by default. You have to put them there yourself. And because you're on a command line, you don't have access to the web browser. So the command that you use to install Anaconda is here. I'll copy it out of the slide and put it into the shell here. Curl -o And then this link, https blah, blah, blah. And you notice here I have Anaconda 3-2024.02-1-Linux x86_64.sh. This is the Anaconda distribution for a Linux computer. That's what this is, this CN458. So this is the distribution that you're going to want to use, except that by the time you get around to doing this, it's possible that there's a newer version. The only way to find out is to go to the Anaconda webpage and look for the most current Linux installation that fits this x86_64 profile, and then just modify this link to include that and run this command. This will download this Anaconda installer into the home directory on this, this machine CN458. But I am not going to run this command because it'll take too long. So you would run that command if you wanted to install Anaconda. And then just to see if it worked, you can do ls anaconda star.sh, and if things have gone well, this asks you to list the files in your directory whose name is anaconda something.sh, and you see that I did download it earlier. And then finally, you want to run the installer, and the way you do that is with the sh command. So you would take sh and that file name, and you would run it. And again, I'm not going to do this. It'll ask you all kinds of questions about where you want the software installed, just as if you were installing it on your local machine. And when you're all done, you should have an Anaconda installation. And if you wanted to see, I have an Anaconda 3 directory and it has all this stuff in it. So that's Anaconda. You only need to do this once. Then you should have it. It should be all set, and you'll have Jupyter and all the things that you need. Okay, now we can get back to the main part of this this whole video, which is how do you connect from your local machine. So the next step is to load VScode onto the cluster node that you're working in, CN458 or whatever it is for your machine. You'll get back this loading VScode 2024, and that's basically the whole thing you need to do to temporarily load VScode. If you're up on your Unix, you could put this in your login profile so that it happens automatically. Otherwise, you need to do it each time you log in. Now we're finally ready to start the remote part of the connection process. We're going to use the command tunnel, and if you type the command tunnel, it'll tell you that it started the Visual Studio Code server, and it asks you, how would you like to log into Visual Studio Code, Microsoft or GitHub? Of course, GitHub is owned by Microsoft. This is really up to you, but if you use the Microsoft account, then you should be able to use your same UConn credentials that you use to log into your Outlook email and things like that. If you have a GitHub account, the process, I'll do the Microsoft version, but you could do the GitHub version. It's very similar. And so let's hit enter and say Microsoft. And it says to sign in, use a web browser, and it gives you a URL that you need to open. So I'm going to take this URL, and I'm going to go up here to a new web page and paste that URL in. And you notice that I get a prompt asking for a code, and here is the code. Whoops. I will take that code and paste it in here. And then you should get the login prompt from your Microsoft account. Now, I'm already logged in, and you probably are too if you've been using Outlook or something like that. So you get this, are you trying to sign into Visual Studio Code? Yes, I am. And you hit continue, and you get this confirmation. So now for the moment, you are done with we're not quite done. What would you like to call this machine? So the default is it will use the prompt name, which is CN458, and that's fine. We'll take the default. And now it says it's creating a tunnel with that name, and there's another pause, and then you get this link. So at this point, there's a fork in the road. You could use this link If you do, you will actually open a whole copy of VS Code inside your web browser on your local machine, and you can work on that. That's one pathway, but that's not the one that I prefer. Instead, I want to go back now to our local machine. Oh, notice here, do not close this terminal window, or you will regret it because all the work that you just did will disappear. You can minimize it. I'm not going to, but do not quit out of it because you need to leave it running. So now we go to VS Code on our local machine, and we're going to do the other end of the connection. So what we do is we start it up and we open the command palette. So that's Control-Shift-P or Command-Shift-P. And we select, if it's not visible, you can type remote, and then you'll see remote tunnels will come up. You click remote tunnels, connect, and it'll say what type of account did you use to start this tunnel? Well, we used the Microsoft account. And then there will be a pause. And then it shows you several, I have done this lots of times before, so I have some old ones, but the crucial one is the one we just made, CN458, and it's online. And I'm going to select that. And then there's going to be a pause. If you're looking at the window that's open on the server, on the cluster, you'll see some dialogue go on. I always get this prompt. I always click always update. It doesn't matter. I still always get the prompt. And now I have this Visual Studio Code window. But if you look in the lower left-hand corner, you see this blue box says CN458. So that tells you that this window is actually open on the cluster. If you go to the file browser and click Open Folder and say OK, this is your home directory on the cluster machine, then you may get this prompt, I trust the authors because the authors are me. This is actually all the files that are not in my local computer, but rather on the cluster. So these are ways of seeing that this all actually worked. The crucial thing, though, is we're now going to open a Jupyter notebook. So we're going to say Command-Shift-P, create. You can type create if you want, or Jupyter, and I'm going to select create new Jupyter notebook. And I get a new Jupyter notebook here inside VS Code. Now, you probably will need to look up here at select kernel. And this will show at least the Anaconda kernel that you installed when you installed Anaconda on the cluster. So that you want to make sure that you select that. Yours may look slightly different than mine because I've messed around with my machine a lot. And now, if this says Python and you've got a window here, you should be able to say print hello world. And it worked. And so the situation that you've arrived in now is that this Jupyter notebook is running on a machine with 32 gigabytes of memory and 8 cores, regardless of what's on your local machine. Your local machine is just acting as a kind of a terminal. And as always, you can you can do some stuff on this Jupyter notebook, and then you can save it. File, save as demo, for example, .ipynb, and it's going to save it on the cluster. It already exists because I was playing around with this earlier. So now we've made a little Jupyter notebook and we've saved it on the cluster. Okay, well, the other piece of this puzzle is you might want to now get this after you've done all this work. Maybe you want to get the copy from the cluster back to your local machine. So you there's lots of ways to do this, including some graphical tools, like there's one called FileZilla, and if you were to go to the knowledge base here, you can read this web page. It's file transfer under the HPC web page. But there's an easier way to do it, which is to use rsync or SCP. These are commands which copy files between computers. So how do you do this? Well, if you want to first of all, you have to do this inside a terminal window. This terminal window that I'm running is already being used to handle the communications with the server. So I would need to open a new terminal window. And let's say I wanted to put a file from my local machine onto the cluster. So you could use rsync to do that. And you would say, what is the file name that you want to put there? I happen to have a file called atom.md, never mind what's in it. But I want to copy it to the cluster. I can say rsync JETO, that's my net ID, the cluster's address. And then, very important, you see this colon. The colon means that this is a machine name and not a file name. If you leave off the colon, all that's going to happen is this file is going to be renamed this, which is not what you want, and it's going to be annoying. But if you do this rsync command, oh, I left off the 2 from the name, sorry. Here we go. It's going to ask you for your password. And you may get this message, which is irrelevant. And if you go back now to the to your VS Code window, which is open on the cluster, you should be able to. There it is. Atom.md got copied to the cluster. What about going in the other direction? Well, it's basically the same. You would say, for instance, rsync, but now you're going from the cluster, HPC2, and then you go colon and then the file name. It could be a full path, but if it's in your home directory, you can just give the name. So let's get demo.ipynb and copy it to my current directory. So this is like a copy command. You could also put here demo.ipynb, and that'll copy it to your local machine under the name demo.ipynb. Asks for your password, always a good sign, tells you that you're connecting to the remote machine. And now we've copied that to our local machine, and we could then work on it here or whatever we wanted to do. So that's a little bit of a detour on working with files. The last part of this is how to quit. And here it's important to be a good citizen because we've done a lot of stuff. We've started a server on the cluster, and we've got a login connection, and then we started an srun into a compute node, and then we created a server. We want to make sure that we unwind all of that stuff. So the first step to unwinding it is to close the remote connection in VS Code. So if you open the command palette and you go to show remote menu and choose close remote connection, it'll shut down the VS Code window which was open on the remote machine. That's step 1. Step 2 is you go back to this terminal window which has the server running in it, and you use Control-C to quit out of it. That kills the server and brings you back to the compute node. Then you type exit to leave the compute node. And finally, you type exit again to leave the login node. And now you've completely shut down your connection to the server, and you don't have anything to the cluster, and you don't still have anything running up there, which is tying up resources. So that's my whole story. I hope you find that useful, and feel free to get in touch if you have any questions.